So this is the introduction of deep learning. Deep learning is a subset of machine learning based on artificial neural networks, and it automatically learns theoretical representation of data and inspired by human brains, neuron structure, applications like image recognition, natural language processing, robotics, healthcare, and finance. This is the mathematical view of neural network approximates a function like input and x and generates the output using some activation function. And this is the equation of y is equals to summation of x w plus bias and where is w is weights, b is a bias, and summation is activation function like sigmoid ReLU. And the network learns by minimizing loss using gradient descent. So this is the basic history of deep learning. In 1943, Michalik-Pitts proposed first neural network, and 1958, Rothbard developed perceptron. 1986, backpropagation popularized, and in 2006, Hinton reintroduced deep leaf networks. In 2012, AlexNet revolutionized image recognition, and 2020's Transformers GPT and large-scale models dominates AI. So this is the first model of Michalik-Pitts neurons. It is the simplest computational model of biological neuron, like binary output neuron, which if the weighted sum is exceed by threshold value, then neurons fires. And the equation is y is equals to f of summation of xi wi minus bias. And x is the inputs and w is the weights. And neurons are in basic neurons. MP neuron is implements basic logic gates like add or and not. So this is the example of logic gates implementation using MP neuron. This is the basic diagram of Michalik-Pitts neuron. There are two inputs like x1 and x2 and corresponding weights w1 and w2 and feeds into a summing nodes followed by the activation threshold output y. So the next is perceptron model introduced by Frank Krosbett in 1958 and a single layer neural network that classifies linearly separable data. This is the equation of output is equals to f of summation of xi wi plus bias. And limitations of this network is cannot solve the non-linear problems like XOR. Multi-layer perceptron. It extension of perceptron with multiple hidden layers can approximate any continuous function like universal approximation theorem uses backpropagation to update weights layers layer by layer, and it has the architecture which having three layers: input layer, hidden layer, and output layer. This is the basic diagram of multi-layer perceptron architecture, which having number of inputs and corresponding weights, and apply the summation on the input and their corresponding weights, and and apply the activation function. This is the activation function. There are some types of activation functions like sigmoid 10H ReLU activation function, which is used in the neural network. And the purpose of activation functions is to introduce non-linearity, allowing networks to learn complex patterns. So this is the process or steps of training multi-layer perceptron. First is initialized weight and bias. Step two is a forward pass compute output. And the third step is compute error, which is loss is equals to target minus output. Fourth step is backpropagation algorithm, which computes the gradients. And the fifth and the last step is update weights using gradient descent and calculate the error. So this is the mathematical equation of backpropagation. So there are some application of multi-layer perceptron like handwritten digit recognition